In a previous lesson, we looked at what a radian is and how it relates to a degree, and now we're actually going to find the length of the intercepted arc. So an intercepted arc is right here. It's where our angle intercepts our circle, and that is called S. We have the formula right over here. S is equal to theta r. You need to make sure you're starring this little statement down here. Theta needs to be measured in radians. If it's not, and it's measured in degrees, you'll have to convert it first. So if they give me theta right here in degree measure, you need to convert it to radian measure like we did last class. Most of the examples that we're in today are in radians, but that's not to say it's not going to be on a future quiz or test. Okay, so first three examples, use each circle to find the length of the intercepted arc. Round your answer to the nearest tenth. So I'm going to rewrite my formula. S equals theta r. In this case, my intercepted arc is right here, and that is actually A. So I'm going to write A equals theta r. R, my radius, so that is 4 inches. And then they also give us 7 pi over 8, which is my theta in radians. So let's plug in what we have. We have A equals, theta is 7 pi over 8, and then I am multiplying by my radius, which is 4. Now in the other examples, it was really important that we kept pi. In these examples, since we are measuring for inches, you've never really heard of 7 pi over 2 inches, so I'm actually going to put it right into my calculator like it is so I can get my answer. So I have 7 pi, that was second caret if you want to use the actual pi button, divided by 8, multiplied by 4. And that gives us 10.9957429 inches. We are supposed to round to the nearest tenth, and that's going to end up giving us about 11.0 inches for our A value. Okay, same concept for number 2. So I'm going to go ahead and write my formula down. In this case, it's M equals theta r. My intercepted arc is right here this time. They give me a radius of 19 centimeters, and my theta is 2 pi over 3 radians. Plug in what we know. M is equal to 2 pi over 3 times my radius of 19. Again, put it right in your calculator. So this time I'm putting it over here. We have 2 pi divided by 3 times 19. And that'll give us an answer. Remember, we're rounding to the nearest tenth, so that'll be 39.8 centimeters. Okay, and last one for the easy ones, we have number 3. We are looking for the intercepted arc, and this time it's actually this longer version, but they don't end up giving us theta for that. They give us theta for the one here at the bottom. So this is my radius, but I don't know what my theta is right now. I need to solve for that. So I'm actually going to move my paper over a little bit so you can see. And this is an aside. You can do this in your calculator. I am going to do it by hand. I need to figure out what this section right in here is. So if I'm measuring in here, I need to figure out what that measure is. So the whole thing, which you learned before, so half of this, we had a radian here, or about here, here, and then this ended up being pi radians. So half of the circle is pi, and then the second half is pi. So the entire circle is 2 pi. So I'm going to take 2 pi, and I'm subtracting out the radian that they give us right here. So minus 5 pi over 6. If I subtract these two things, I'll be left with what's left, which is what we're actually looking for, what radian measure we need. So I'm going to put this over 1. We need to subtract fractions. It's been a while, right? Multiply by 6, I have to have a common denominator in order to subtract fractions. So I'll have 12 pi over 6 minus 5 pi over 6. So 12 minus 5, that gives me 7 pi over 6. So that's an aside. We don't need that for the entire problem. This is just to figure out what the measure is in this section, which is 7 pi over 6. So the next step is to plug everything into our formula. We're looking for W this time, so W equals theta R. Theta we just solved was 7 pi over 6. And my radius this time is 4 centimeters. Plug that into your calculator. We have 7 pi divided by 6 times 4. Again, we're rounding to the nearest tenth, so that is about 14.7 centimeters. So that's if they give you an actual circle. You can solve for it pretty simply. But in number 4, we have an application problem. Our first real application problem of this chapter, really. So let's move down and read what it's got to say. So the minute hand of a clock is 8 inches long. So really that means we have a circle, and our minute hand, this is a clock. This would be our 12, 6, 3, 9. And our minute hand is 8 inches long. We're going to assume that it goes straight to the edge of the circle, and that will be our radius. So we have 8 inches long, that is our radius. And we are looking in part A, what distance does the tip of the minute hand travel in 10 minutes? Well, unfortunately, 10 minutes is not a degree or a radian measure, so we are going to have to figure that out first. So I'm going to actually set up a proportion that will help me along the way. So we have 10 minutes, and how many minutes are in an hour? Well, that's 60. And then we have what we're looking for, so x, over 2 pi. And this is going to give me x in radians. I'm using 2 pi because the entire circumference here, this is 2 pi. So if I'm coming, this measure we know is 360 degrees, and it's also 2 pi all the way around. So cross multiply. Cross multiply and divide. Everyone should know how to do that by now. We have 20 pi is equal to 60x. Divide both sides by 60. And just like we had done before, I'm going to reduce that fraction. So 20 divided by 60, if you can't do it in your head, is 1/3. So we have pi over 3 for my x. Now that we know the radian measure, I can actually use my formula. So S equals theta R. I'm looking for the distance, so I'm looking for my arc length. We just solved for theta, that's pi over 3. And my radius, they gave that to us at the very beginning, that's 8 inches. Use your calculator. We have pi divided by 3 times 8, which is 8.3, and I'm actually going to round to the hundredths this time, 8.38. And that's inches. So if I'm going 10 minutes, which would be, from around here all the way up to about here, that would be about 8.3 inches. And that's about 60 degrees. Okay, part B, Same concept, we just have a different amount of time. So we have 40.5 minutes. I'm going to start off by making my proportion. We have 40.5 minutes for 60 minutes equals, looking for my radians, over 2 pi. You could use 360, but then you'd have to go ahead and convert it all anyway, so you might as well just use 2 pi. So 40.5 times your 2 pi, put that in your calculator. You have 81 pi is equal to 60x. You're dividing both sides by 60, just like we did before. And x equals, remember, I'm reducing 81 over 60. 81 divided by 60, math, enter, enter. 27 pi over 20. So 27 pi over 20 is my radian measure. Plug that into the formula. S equals theta r. Theta is 27 pi over 20. And my r has not changed. The minute hand is still the same. Multiply that out. We have 27 pi divided by 20 times 8. Again, I'm rounding to the hundredths this time. 33.93, and that's again in inches. Letter C changes it up just a little bit on us because we don't have minutes, we have hours. So before I can actually even set up my proportion, I'm going to write my 3.25 hours as minutes. And how are we going to do that? Multiply by 60. So 3.25 times 60. That gives us 195 minutes. So this was 60 minutes over 1 hour. And over here this was an hour, so they canceled each other off. So that's how I was just left with 195 minutes. Now that I have that, I can set up my proportion like we did before. I have 195 minutes over 60 is equal to my x radians over 2 pi. Cross multiply and divide. I'm going to just give you the answer for one. 13 pi over 2. So S equals theta r. Plug in our newfound theta. And plug in your 8 inches for the minute hand. We'll get about 163.36 inches. And we have one last one. So at the very bottom here, after approximately how many hours, so I'm looking for something a little different now. Hours, has the tip of the minute hand traveled 100 feet? Well, all of our A, B, and C's have been measured in inches. Now we have feet. So I'm going to have to take 100 feet and multiply by my 12 inches in 1 foot. That's, of course, 1,200 inches. Now, there's a few things I can do here. What I'm going to take is actually the answer that I got up here and apply it to what I have down here, because this was measured in hours and I'm looking for how many hours there were. Instead of doing so much work, we might as well just use what we found before and apply it to what we have now. So I am still setting up a proportion, but this time I'm going to set up the fact that we had 3.25 hours. And we found out that there were 163.36 inches in that amount of time. I'm looking for how many hours it would take. And then finally, we have how long or how many inches there are in that amount of time, which we found out was 1,200. Cross multiply and divide. You will get 23.8, which I would say that's pretty close to 24 hours. So it takes approximately an entire day in order for the tip of the minute hand, which is 8 inches long, to travel 100 feet around. Okay. Now for my class, we are going to do a little bit of practice, which will be handed out to you. And then we are going to practice, converting from radians to degrees, vice versa, and then working with our arc length formula. Thanks, guys.